Okay, you can pause the video and attempt the question yourself. Otherwise, the question says a function f of x is continuous on the closed interval 2, 5, with f of 2 being 17 and f of 5, 17. The question says which of the following additional conditions guarantees that there is a number c in the open interval 2, 5 such that f dash at c should be 0. In other words, the derivative at c should be 0. So it is smart to kind of make a rough sketch to see what's going on with the function. Okay, so they give you f of 2 is 17, so maybe here. And then f of 5 is 17, 3, 4, 5 is also 17. So that's all that's given to us. And you're also given that the function is continuous over this interval. So here are all the different ways we could conceivably draw the function f of x. We could draw a horizontal line, in which case over the entire interval, open interval, the slope of the tangent line, so if c is any value in between 2 and 5, then the slope of the tangent line f dash at c will be 0. So this is true. But this is not, the horizontal line is not the only way we could draw the function. We could also draw a function like this. Okay. In which case you can see you have a horizontal tangent there, here, and then here. So you can say C1, C2, C3. So we have 3 different values. And of course, we could potentially have infinite. So you can go like that. I could have infinite values where f dash at c equals 0. Okay. But remember, all you're given was the function was continuous. This is also a possibility. How about this? So maybe you have a graph like that, in which case, when you have a sharp corner like that, the slope of the tangent line actually does not exist. Okay, f dash at c does not exist. We cannot take the derivative. So for the derivative to exist, in other words, we're making sure the derivative exists. And let's read the choices. It says no additional conditions are necessary. No, we should be able to take the derivative at every value c in between, in the open interval 2, 5, okay, in between 2 and 5. It says you have a relative extrema in the open interval 2, 5. That would be true if you drew one of these graphs. So we have a relative extrema. But that does not take into account this kind of thing. The concept of relative extrema is just that f dash switches signs. While f dash is switching signs over here from negative to positive, at the critical point C here, f dash does not exist. Okay, so the concept of relative extrema is also that it's defined, the slope is defined at that value. D just says the integral or the area under the curve from 2 to 5 should exist. That would be true as long as f of x was continuous. We could find the area. So the correct answer is actually C. F of x must be differentiable in the open interval 2, 5. If you actually think about it, this is actually the mean value theorem. Okay, so it's called the MVT, or the mean value theorem. According to the mean value theorem, the conditions are that f of x is continuous in the closed interval 2, 5 and differentiable in the open interval 2, 5. So this was basically testing the concept of the mean value theorem.